Okay, so we're going to look at sort of start analyzing network packet capture. And one of the things we're going to do is start sort of looking at these, the top in questions is what I call them. So I've already got my Kali machine started up. What I'm going to do is log in, Kali. Anytime I hop onto Kali, I always like to verify that I can get to the internet. Oops, pinggoogle.com. You can see that it's working. I'm going to hit Control-C to cancel and clear it. And just so we can sort of look, I'm going to open up Visual Studio Code. And I'm going to paste in those questions. And the questions, really just a starting point to maybe start pulling threads. So let's see, who are the top in talkers? So these are like my top in questions. If you're doing like incident response at the network level, you want to be able to answer like, who is communicating the most on the network? Who are they talking to? They're communicating, but who are they communicating with? Is there any kind of pattern? So let's talk a little bit about frequency. Is it happening once a day, twice a day? Is there any kind of pattern you can discern? How much information are they sending? So this one is kind of interesting. So are any of those endpoints known to be involved in malicious activity? So you can first of all, get a list of the IP addresses in this packet. This packet capture. And then sort of ask the question of I'm going to say something like Google, right? Is this known to be malicious or not? And there's some tools that we can look at to explore that some more. So let's see, the protocols. Do they spend more time talking over TCP or UDP? And I think this one about outliers are interesting. So yeah, you might have a lot of normal traffic on the network, but there's one instance of, we'll say IRC. You don't use IRC on your network at all, but yet for some reason there's some device on the network communicating via IRC. That's an outlier. It's not the top N, it's the bottom N in that instance. So just kind of think about outliers. That's really what these questions are about. So I'm going to leave that open for the time being because we're going to kind of reference it, and as we come up with answers to those questions, we're going to, I guess, actually start doing that. So let's see. I'm going to go here. And in order to do this, we're going to need to download a file. What you can do is open up your Firefox. Go here, Firefox, and this link should be in the slides. And I'm going to paste it. What this is going to do is just prompt Firefox to, hey, do you want to download this file? All right, and I'm going to go ahead and tell it to save. It shouldn't take too long. And the file we downloaded was called hackersonthenetwork.pcapng. So I'm going to go into the downloads folder in the terminal. And let's see, what do I have here? I'm also going to open up the folder. I'm just going to double click the icon to show you. Open folder. If I go to my downloads, you can see hackersonthenetwork.pcapng. So if I double click it, it's by default, it doesn't know that it should have opened that file with wireshark. That's unfortunate. It really should. If we scroll down to the bottom, there should be, it's sorted alphabetically. There's wireshark, and then you can use as default for this kind of file. I'm gonna hit OK. And it should have opened. Let me try to double click it again. Ugh. Why is that not working? All right, so the other way that you can open it, generally, if you have like a .pcap file or something, you can double click it in Kali. But the other way, we can go to the application menu, type wireshark, open it up. And this time, maybe that's why, because maybe the shortcut prompts you for elevator privileges, and it doesn't have a way to do that without, I don't know. Anyway, just do it this way. Just go to the application menu, type Wireshark, and we'll navigate to it. So I'm typing Kali to log in. And just like other programs, you can go to the file menu, you can open files, right? The only caveat here is that it opens in the root folder. So again, this is why it's just kind of important to recognize how to navigate through your Linux file system. Know that all things come from the root of the file system. So if you can get to the root of the file system, you can navigate to the home folder, to the Kali folder, to the downloads folder, and then there's your file. That's one way to do it. I don't know if you can drag and drop. Yeah, it looks like you can also drag and drop. So if you were to just click on Wireshark up here, I'll go ahead and close it. Wireshark, Kali, drag and drop. So more than one way to raise a cat. Real quickly, I'm going to give another brief overview of all of the things that we're looking at right here. There's a lot going on, but all of it has a purpose. All of it is understandable, and it all means something, and none of it's random, right? Hopefully, you can see that well enough on the screen. I'll try to zoom in just a little bit more. There. Okay. So what we're looking at right here, where my mouse is kind of moving up and down, there's all these rows. I can click around and you can see that it stays highlighted. This is called like the packet summary window, and it shows things kind of in context next to each other. It's all sorted by this number column. By default, it comes sorted by this. This one is the first packet that it received at the start of the capture. When you pressed record on the packet capture, this is the first thing that it encountered. You can sort by these columns. Sometimes it's useful to see that, but do note that it's no longer in chronological order. So if you wanted to get it in chronological order, you'd have to, well, basically just click on these columns. Just like in Excel, you can sort, and it keeps all the rows, in the appropriate place based on that sorting. So we're looking at a couple of things. You can right click up here and add different columns, particularly I think if you go to the view and you can add in different layouts, basically. You can add additional information to the columns. These are good default columns. There's some stuff you can add. For our purposes, we're not going to explore that a whole lot. Things to know: protocol. This shows not just the basic protocol, but it shows you kind of at a certain level the highest layer up the OSI model that it's aware of. So in this instance, DNS, it knows that this is an exchange using the DNS protocol. Generally, DNS operates by UDP. There are ways that it operates via TCP as well, but generally it's UDP. So when we look at this next section, you can see that it's kind of in the OSI model inverted. So this is the lowest bits on the wire, right? What they call a frame. This is the lowest layer, the actual wiggling of electrons across the wire, on, off, so on and so forth. One layer higher is Ethernet. That's where MAC addresses live. One layer higher is the IP layer of the OSI model. And I guess sort of still in that, the session layer, I guess you have UDP. Well, again, we said domain name system generally works via UDP. That's why you see UDP and DNS sort of adjacent to each other. So right now we are looking at a bunch of things. This is all of the DNS requests that are, seems like the response and the query. So somebody asking what website is this, available. I'm sorry, someone asking the question, what website is this available at? And someone responding. Do note that chronologically, this doesn't make any sense, right? Because this was the 11,000th packet. So if I'm sorting on DNS, I'm not getting a true representation of what is, what actually is happening. So the only way to know, to build a timeline of these things is to be sorted on either the packet number in descending order or ascending order, or the time. So this time represents 146 seconds since the beginning. And unfortunately, I can't break those two apart anymore. 147 seconds since the beginning of pressing the record button. So there's ways to manipulate this. I go to view and then time display format. I can do, let's see, you can do UTC, day and time, but let's do year, day of year, and time of day, time, da, 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 da. I think this one makes the most sense. It gives you 2017, September 19th at 0400 and 22 minutes, 13 seconds, and then some decimal beyond that, right? Very, very precise. But that also kind of gives you like, oh, so-and-so tried to visit or looked up the website at this date and time. This date and time is actually stored in the PCAP file itself as just part of the metadata of the file. And that's how it's able to derive this. It knows that 147 seconds later, this thing was encountered. This particular packet was encountered. So the next most important thing I'd say is probably this display filter. I'm going to go ahead and sort based on the packet numbers again, and it looks like I have them in ascending order. So it's like the numbers are getting bigger as you go down. And say I want to look at all of the web traffic, or maybe let's try, or DNS. Let's look for just DNS. You can put in really interesting, complicated, long queries, and they have some of those built into a cheat sheet for you in the slides, as well as in the, I think, the hacker methodology handout as well. So right now I'm looking at everything that is matched. It contains basically DNS as part of the protocol. Something else I can do is I can single out a host. A host is either going to be a source or a destination in IP communications. So if I say IP.addr, the IP address is equal to, and this is kind of like the same equals in other computer science concepts. If I say it's 192.168.1.9, these are all the communications that this host was either the source of the communication or its recipient, the sender or the receiver, right? If I want to find out just the things that they sent, I can do SRC. If I want to find out just the things that they receive, it could be just DST, right? But if you want to get the entirety of the conversation, you can do some other things. This last part is the packet details. I'm going to look through this particular thing here, this packet, the one that's highlighted. I can break it apart and sort of look in greater detail where, what this information is. But this is the hexadecimal representation of the data that's going across the wire, the entire packet. So this 10DA43, as that's highlighted, you can see that that's actually like this entire frame encompasses all of this. So we talk about encapsulation and wrapping things up. That's what's happened here. We've encapsulated this into an Ethernet frame, or frame on the physical link layer. Just so happens, I think this was Ethernet. So at any rate, now that we kind of have like a lay of like what the filtering can do, and you can add in complex DNS, right? So I can say I want to see everything where this IP was the originator and its DNS, not just DNS, but I want query type. So I can say, I want to see all the DNS queries that they made. You can drill down into these. And again, these things are available as cheat sheets, or a bunch of like really useful ones are available as cheat sheets and the thing. So we can see that chronologically, these things all happened. And we can look and see that many of them happened within fractions of a second of each other. So as you load a web page, you start loading other resources at other web pages. That's just the way the web is built. So, all right, so I'm going to clear this filter and notice that this only sort of temporarily reduces what you see. If you're capturing things in real time, this display filter, you're still capturing everything, but you're only showing a subset of it. So it will get slow if you let it run this way for a long time. So there are command line versions of these tools that are a lot more efficient rather than like having to update a GUI all the time. It shows it just in regular, just plain text. So we'll explore some of those. So let's see. We have our top end questions. Well, what were they? What were the top end questions? Who are the top end talkers on the network? So that's what we're doing here. We're going to try to answer some of these questions for you in this lab. So this is a useful skill. You can use this on a home network, a corporate network. The concepts are going to be the same. From the GUI, what we can do is go to statistics. And then I believe you can go to conversations. And if we sort of just kind of keep in mind what the objective is, these are Ethernet communications. These are going to be communications that take place on the local area network. We're interested in likely communications happening to the internet. We can look at these various tabs and what they kind of represent the various layers, like IPv4 and IPv6 are kind of adjacent. TCP and UDP are going to be serving different properties. Different purposes. But for the time being, let's just look at IPv4. And the way that this thing is sort of laid out, you can again sort on these columns. So you could sort by address A being the source, B being the destination. And you can, this is lining up all of the conversations. So every instance of communication. And right now, it may not make a lot of sense to sort on these unless you know you're looking for a certain number of IP addresses. That way you can sort of find them quickly because it's just going to sort them numerically. What I think is particularly useful is sorting on bytes. So right now I've sorted in descending. I want to sort it in, I guess, ascending. And if I scroll up to the very top, it should show. And can I zoom in on this? I can't zoom in on this window, unfortunately. That's unfortunate. It's going to show me the communications that are the largest based on the raw number of bytes exchanged as a whole. If I want to find out the like where source A is sending the most information to host B, I can sort on the bytes column for A to B. If I want to find out where B is sending the most bytes to host A, say that's in the responses, I can sort on these columns. So I mean, this is one way to start answering that question. I can see that, 192.168.1.9 communicates with 216, 115, 100, 124. They send a total of 1,207 packets for a total of 1.7 megabytes, thereabouts. So let's say I wanted to find not just the top N, but like say the top 3. N equals 3. So let's see. On my network, and again, from my perspective, I can say that the 192.168.1 network is likely my network. So I can say 192.168.1.9, right? That person is a top talker, and very likely. I do see that they're involved in almost all of the communications, to be perfectly honest with you, where they are address B. So, right. Scrolling around. This is 4,000. So, okay, there we go. 1.7K. So but that's not the largest instance of communication. 16K. Why? 41,000. 9,000. Okay, 25K, 10K. These numbers, that's 17K. Oh, okay. I don't know why I'm thinking like 1,000 is less than 12K. 1,000 is less than 12K, but it's not less than 1,700K. Okay, so yeah, my fault. I was adding zeros incorrectly. So that person is there. Let's see, what was another question? Who are they talking to and how frequently? So let's see. There's another tab in the statistics. The statistics is going to be a really useful menu. If you go endpoints, packet links, IO graphs, there's a protocol hierarchy. So we can use this to find out what are the most frequently used and infrequently used packages, or I'm sorry, not packages, but protocols within this video. So let's see, it looks like Google Quick is it sticks out to me. It's, a newer protocol. But I see there's SMB, a little bit of SMB, user datagram, this raw data. It's interesting. So that's all under, yeah, that's just raw UDP packets. Let's see, raw data, raw TCP packets, websites, plain text websites, pictures. It looks like most of it is UDP. And then on top of UDP, we have SNMP, NetBIOS, and SMB. But by and large, it looks like most of the traffic is web traffic, or at least TLS traffic. I don't know that it's web specifically, but it's TLS. And then HTTP. And then, or followed up by, I'm sorry, actually, I guess the second most would be UDP. And then we know that this is likely web, and then DNS. There's a lot of SNMP going on for some reason. So apply as a filter selected. So that was something I did. You can right click on most of these columns and apply as a filter, and it will put it in the filter bar for you. So you can close this window. And this is SSDP is the Simple Service Discovery Protocol. And that's just kind of a way for your computer to automatically discover like newer printers on the network, or maybe Xboxes or TVs and things of that nature. Looking around, just kind of scrolling through. I'm going to see that. I mean, that's, just one thing. So it's UDP. We know that 9 is there, 6 is there. I'm looking for UDP. IP.ADDR equals 192.168.1.9. I want to find all their communication. So I'm going to go up to the very top, sort of chronologically. It looks like they load Google, they hit Google, they actually get, they start an encrypted communication using G-Quick, so possibly using the Chrome browser, because I imagine that would be, in 2017, that would have been among the first browsers to support this particular protocol. So maybe that's them hitting Google and some other resources. They hit some websites. They hit Taboola, OTF, that is. It looks like, okay, so now they're doing some TLS, which is again more web, most likely. Now, one thing, we can look at these certificates, and these certificates mean things, right? They they're associated with corporations, with individuals, with servers, TLS, certificate. Like part of this should identify like who they are, you know, what organization is responsible for them. And you can dig in on a lot of these things and find them. So we can see here, this is a plain web page request. Do we get, it looks like they try to load just the web page msn.com unencrypted. This is more of this information. Sorry, I know this part's kind of boring, but one thing that's interesting, what I can do is I can right click one of these packets and you can follow TCP stream or HTTP stream. So what this will do is if you find something interesting in one of these middle packets, I can see the entire conversation sort of in context. That where red is what the client requests and blue is what the server sends. Now, part of this will be, it doesn't look like much of a web page right now, and it looks like, oh, maybe that's encrypted. It's actually just compressed. That's what this gzip deflate represents. It's kind of, think of it like zipping it and then sending it to you, and then your computer will automatically unzip it. That's what gzip is. It's sending all this information. Then you make another request for a particular image, and there's nothing at that particular, I guess you're making a request for what? Get/undefined. And they're saying that exists, but there's no content. So anyway, that's a useful trick to be able to sort of hunt down things. Let's see. Oh, we didn't answer our question about the protocols, the top in protocols. Top protocols. And again, you may not have an answer to all of these things, and depending on how much time you have to dedicate to it, you know, it may just be a thing that you don't really get much of a resolution to right now. So notice I didn't get the results I was expecting right there. I went to statistics, protocol hierarchy. PHS is protocol hierarchy statistics. What this page does, what this tool does, is it shows you what's in the packet summary window, or basically what's being shown by the display filter. I've said I want to see TCP stream 1. That's the first TCP stream. I can look at the second by doing this, and my packet protocol hierarchy statistics will be different. What I need to do if I want to get the overall is remove the display filter. So statistics, protocol hierarchy. Now I have a more full representation of what's actually there. So it looks like most of it. So I can say that most of it's going to be TCP, but we know it's either going to be TCP or UDP. We're more interested in, it looks like TLS, so some form of encrypted communications, web traffic. UDP is quick. So where's our thing here? Top end protocols. I think TLS has it beat. TLS at 17%, and then followed by G quick. I think now you'll see a newer thing. I think it might just be quick. G quick is 14%, and then HTTP is 5%, and DNS is 4%, 4 or 5% again. It's fine. So what's funny about that? Let's look at our bottom end. LLMNR. This is interesting. I want to reply as filter selected. LLMNR, local link multicast name resolution, is a feature that makes it to where you don't necessarily need DNS to find names of other Windows computers on the network. And it's very common in penetration tests to run a tool called Responder, which will lie about who you are on the network, and it will kind of force machines to send you their credentials as part of like their authentication process on their network. So interesting that LLMNR was there. So had you seen a lot of that, maybe that would be something you could find and consider part of your bottom in. I can see that SMB is there, not a whole lot. You can see there was only actually 2 packets worth of that. So 2 packets worth of LLMNR, 2 packets worth of SMB. Let's see. 8 packets of raw data. What is this going to do? Apply as filter, just data. So this might have just been an error in you might have missed some packet, right? Or the machine capturing this information might have just dropped a packet. So says previous segment not captured. Maybe that's what it is. It was just a hiccup. That happens sometimes in packet captures because you're receiving all of the information from a particular machine. And what is this? Okay. Send API, yeah, back, yeah. Okay. I don't know what this is exactly, but it's interesting looking. Just information. I just kind of called out a protocol. It again knew that it was HTTP, but that inside of that HTTP, it was transporting JSON. In this instance, it's transporting XML. So those are interesting. Let's see. That's it. Just kind of dig around in some of the menus. The command line versions of these tools are really powerful as well. We can take a minute and look at some of those real quick. The long and the short of it is, and again, we'll have some of the killer moves, I think we call them, right here. So if we wanted to find, there's a tool called tshark, which is the terminal version of wireshark. It's the terminal shark, right? You can use tshark to get that protocol hierarchy statistics pretty quickly. We're in the same folder as our download or as our hackers on the network. So if I ls, it's hackers on the network right here with spaces. So I'm going to copy that. It's tshark, and you need to tell it to read a file, so tac R. In fact, before we do that, I'm going to maximize this, zoom in a bit. Just run tshark-h. See what it does for you. It tells you a bunch of stuff, all the commands, all the flags you can feed it. A lot of the things we're going to look at are under the tac Z for statistics. And then we're going to be filtering out a lot of this information. So let's see. What are we looking at? Okay, we were going to get the tshark dash N stands for name resolution. It's good operator security or operational security for the operators, the incident responders, to not resolve DNS names. The idea being is like there could be a canary, and if they know that you resolve a domain name that they're supposed to be resolving from an IP address that they aren't expecting, they can know that their operation is burned. And so it's best not to resolve names. I wish they would make it to where you have to opt into resolving names as opposed to resolving them by default. But just tac N stands for that. Q stands for quiet, not mean. So that we want it to be to suppress, like, don't show the version number of tshark, because we're not interested in that. We're interested in statistics, particularly building a pipeline to answer these questions, maybe using a script. So we want to do that, and then we want to tell it to read a file, read with R. And then which file are we looking for? We're looking for the file called hackers on the network. I use tab to finish out that path for me. Now, just doing that will do a lot of interesting things. Sometimes when you don't have the queue on, actually, the queue doesn't do anything. Queue makes it do nothing. Sorry, except for some other things. So this kind of gives you that same summary that we looked at in the terminal, except now you could use grep. Grep, 192.168.1.9. There's more efficient ways to do this using the display filters. But if I was looking for a particular word, for instance, I knew, and there's always going to be a more efficient way to use the original tool rather than the output of one tool and passing it to another. But if there's no better way, you can kind of see. I guess the nice benefit is it does sort of show you A, B, sort of shows you direction to direction. I don't know. Using display filters, -Y. Unfortunately, I wish they had a better name for it than that. We can do the same thing. IP.addr equals 192.168.1.9. That's the same thing. Effectively, it's only going to show me packets that match that. Whereas in the previous example, I put everything onto the screen and then only showed. So it would probably take longer to run this version than the display filter version, because wireshark is just not even going to the trouble of printing packets then. So just a thing, just understand you can build a pipeline with it. So one of the statistics we're looking for, -Z, is statistics. And this is one of those things that's just almost rote memorization, or have a cheat sheet, IOPHS. So you're looking at input output statistics, and particularly the packet or protocol hierarchy statistics. Oh, I'm sorry. And that's why you want the queue, because it does the PHS at the end of rendering all that stuff. So we tell it to be quiet, to not put anything onto the screen. We're just going to get the output of this this little chart, right? And we got kind of the same answers as before. There were 2 frames, so many bytes. There's a lot of TCP bytes. Not all of those TCP bytes are TLS. Some of them are plain old HTTP, right? And so you can use this tool to sort of quickly get this chart, right? And what am I saying? You could, I don't know, you could find a way to filter if this number is greater than or less than. If you know that if you ever see IRC on your network, if you see more than one IRC instance, raise a red flag somehow. So that's one. We can find our top talkers on the network a little more easily, a little more deterministically, I guess, and not as subjectively, I guess. Endpoints, IP. So this is big, and it shows you, again, top talkers sort like in sort of descending order. Overall, it's sorted by this packets count. Now you can have different packets that are of variable size. So that's what the MTU stands for, the maximum transmission unit, or maximum transmission unit, like the size of a packet. So just bear that in mind. This is based on the number of packets that they send. It's a great starting point. So these 3 IP addresses are top 3 talkers on the network. And it just so happens that this one is internal and these 2 are external. So these 2 are likely talking to this one. I say likely, I mean, I have no reason to know that. I'm guessing, that's my intuition, having seen this packet capture a couple of times. So another interesting one is conversations, like the destinations. So conv, same thing, and it shows you a little bit of directionality, like between the two units. Same thing, right? We can see that this IP is communicating with that host we were talking about a second ago. Same thing with 172, the 172.217 address. Now it does show you, this is interesting, length and the duration of communication. I think that's in terms of seconds. If I might be, I don't want to, let me lie about that. But at any rate, so what websites, what DNS requests are we doing? So if we look at tech T, I'm gonna do that to sort of break it so we can look at this menu real quick. We look at tech big T. Let's see, where did that go? It's in here somewhere. Big T, here we are. This line. This can be kind of confusing. Some of it's just kind of a bit of incantation. You have to just remember this is how they built the program to work. If you say tac big T fields, you can then use the E separators, the tac E separators, to list off kind of like a display filter. If a packet contains that field, it will show it. So what do I mean by that? Fields. If a packet -E contains DNS, unfortunately, let me unpin that. If it contains DNS dot, I'm going to do query QRY dot name. It will show that column. It will show that value. Right? Otherwise, it will show a blank line. In addition, oops, I'm sorry. In addition to this field, I want to see not only that query, but I want to see tac E, the IP.source that requested it, the source of the query, the DNS query. So I'm showing, it's kind of like these two columns. If we go back to our wireshark, it's kind of like the source column. It's like being able to remove the time, packet number, length, so on and so forth, and show just those. Okay, where I'm at. So let's try this, and we're going to build a more complex command out of it. So right now, I'm showing a bunch of empty requests. That's because those packets did not match my display filter, right? It did not match, but I did see some. I want to scroll up till I see at least a couple. Here we go. iecvlist.microsoft.com, and then what would be, I imagine, a tab character, and then 192.1.1.1.19. Okay, cool. So what am I getting at here is I want to remove all of these lines that don't have a field to display right here. And that's what we did with our display filters, right? So if it doesn't have a particular attribute, don't show it. The way that we can do that is with that tac Y. And I guess this is makes it a little bit easier. You don't have to remember the tac Y. You can just wrap in quotes the last thing you want to put on there. So if you know that DNS flags exist, and the response to that flag is equal to 0, meaning that this is, if we look at a DNS query real quick, I'm going to do this off to the side and then do this off to the side. Will that help? I'm going to find DNS.query. Oops. Let's just do DNS, and I'm going to find a query. If I look at flags, okay, doesn't matter. Response. So this is a response. This means there is a server answering the question, where is google.com? Google.com is at 1.2.3.4, right? So where this flag is set to 0, meaning it's not a response, that should be a request, like logically, right? So let's see what happens if I hit enter. Okay. And it looks like these are all of the websites that were attempted to be resolved by, I guess this host 192.168.1.9 tried to go to all of these various websites. Wayfair, Mookie1.com. That's kind of suspicious. I don't know what that is. RFIHub.com. That's weird. RFI's remote file inclusion, and then Hub. I don't know I have no idea what RFI Hub is. Chartbeat. I mean, I'm just looking at stuff here, really. So these are all websites that were attempted to be visited. So from our Linux command line, we can remember we always we can sort things by sort of building that pipeline. I'm going to pass that to the sort tac u. Or actually, I'm just going to sort, and then I can do unique, and then I want to get a count of all of those things. So this will eventually show up, but remember, we have to sort it one more time. I always forget that. Sort tac in. So it looks like this person is really interested in bbshistory.org. They're also interested in wpad.asu.edu. Interested in takoda.at.walla.com. I don't know what that is. So yeah, looks like they also went to WebMD a couple of times, Tumblr, text files, just websites. But they visited this site intentionally the most. So that's maybe something interesting, worth noting. And then all these single hits, these one dot whatevers, those may or may not be indicators of anything. If you had one website that is very uninteresting looking, but is hit a lot, that might be an indicator of what am I saying? I guess some repeated attempt to communicate with that service, right? So there's some process or program in the background trying to communicate with it over and over and over again. So, so that's using, like, getting some DNS requests, and we'll look at some of that some more. But this is a high level kind of overview of the capabilities of it. Will you learn and memorize all of this stuff? No, absolutely not. Do you need to memorize all of this stuff to get a job in InfoSec? Absolutely not. Do you need to have mastery of all of this in order to teach it to someone? No, absolutely not. You just need to know that it's possible. So that being said, like, don't get discouraged. Just kind of think, what would be useful information to be able to answer if somebody came to you asking. And I think who's talking the most on the network, how frequently are they talking, what protocols are they using to talk, how odd is it for people to use that particular protocol on a network, things of that nature. So that being said, I'm going to go ahead and stop this recording. If you have any questions, comments, concerns, please reach out. I like network forensics. I think it's a fun thing. So all right, we'll talk to you later. Thanks.